Assalamualaikum and very good evening to everyone, especially to Madam Dr. Hana. So right now we are from the group Three Stooges. Today we will be presenting the summary of our lab work in subject of electrical circuit analysis for Lab 1 to Lab 4. This lab are focused on core DC circuit principles such as Ohm's law, series parallel networks, the superposition theorem, and the Thevenin theorems. All right, for next slide, I will be introducing our group members. For the group leader is Muhammad Haziq bin Roslan. He managed the project timelines and the progress of our work, and he also do the simulation and the calculation for Lab 1 and 2. My teammate, Muhammad Zaim Aiman bin Zulkifli, he the report writer. He used to do his job by compiling the lab reports and prepare our meeting notes. He do the simulation and the calculation for the Lab 4. And as for me, Muhammad Zamzam bin Zulkifli, I am the slide creator. I designed and prepared the slide presentation, and I also conduct the simulation and the calculation for Lab 3. Okay, next slide. For the lab overview, Lab 1, the overview is about the Ohm's law, and Lab 2 is about series parallel DC circuits. Lab 3, which is my lab, it is focused on superposition theorem, and the Lab 4 is on about Thevenin theorems. All right, next. For Lab 1, I will pass to Muhammad Aziz, our leader, to explain about this lab.
Zee, kau mute mic. Kau punya mic tu kau mute.
Oh, sorry. Thank you, Zaim. Thank you, Zamzam. Okay. For the Lab 1, actually, we used to do in lab. So basically, for Lab 1, our main objectives to determine the voltage current relationship in DC circuit verified with the Ohm law, with the Ohm law. So for equipment, we use DC power supply unit, condenser board, and then emitter, voltmeter, and LCR data bridge and resistor 470, and then 2.2k ohm, and then 1000k ohm resistor. Next slide, please. Thank you. So for the procedure, for the procedure, first procedure, construct the circuit shown below with R resistance 417 ohm and check the color coding for resistor that measure is the value accurate using the LCR data bridge or flaker. The third one, integrate set the DC power supply unit to 1 volt and then measure the value current the circuit and record the reading in the table below. I will show later the table. So, and then number 5, increase the value voltage and 1 volt and frame the measured the circuit for each value. Complete the table value below and repeat the procedure 1 to 5 for the resistance 2.2k resistance, and then for resistance 10k too. And then plot the graph V vertical against 1 horizontal, then for resistance 470, and then for resistance 2.2k, and then for resistance 10k. And for the next slide, please. So for the simulation, I use every circuit. Next slide, please. So this one is for the simulation and the calculation for the 417 resistance. So basically, for the calculation, we use IR to get the to get the we use ohm law for the calculation. Basically, V sama dengan IR. So I apa V is 1 and I is 417. So we calculate dapat 2.3 X 2.3 darab dengan 10 10 minus 3 10 minus 3 and then that calculation darab lagi dengan 1000 and then we got the measure of the for vote 1 and then we repeatedly use for others like vote 2 vote 3 vote 4 until vote 8 and then we get the result. So next slide please. This one we use the same concept with the 470 resistance 417. So we use, but we change the 417 resistance to 2.2k ohm resistance. So we just use the same concept to the this calculation. Next slide please. Same goes to the calculation. We use the same calculation as a 417 resistance and 2.2k ohm resistance. Next slide please. So this is the graph. So the vertical against one horizontal for R 400 for resistance for the resistance 440 kilo ohm and then the same vertical. So overall all the vertical and horizontal. So next slide please. So this the comparison between calculation, simulation and practical. So basically last week we do a practical. We not get same as simulation and calculation. Simulation and calculation based on the data that given and the practical one is we use item the item that measure is different. This is different between the data that given on the lab. So for practical, we get resistance not truly 470 ohm, but we get 462 ohm. So and then the measure of course different different with the calculation and simulation. Simulation and calculation is the same data we get. So overall it's not tepat each other. So next slide please. So for the lab 2, our objective to compare calculation with the measure value, voltage and current in series parallel DC circuit. And requirement that required is DC power supply, calculation board and ammeter and voltmeter, Frankel and LCR database. Next slide please. So for this we need to construct the circuit as shown below the image before and check the color coding resistance. The measure is value accurate using the LCR database. And then for the second one, we need to state the color code each the 5 resistance in the above circuit and record them in the table below. And the third one, we are using a factor or SI bridge to measure the accurate value of each resistance and not the value in the table below. And with the ammeter and voltmeter or factor, measure the voltage drop and current the record them to the table above. So basically later we will show the table. Next slide please. So as a lab one, we use same simulation which is every circuit simulation. So next slide please. So this is the simulation that carried by every circuit. Next slide please. So this one is the resistance that this one is the procedure 3, which is we need to measure the actually measure the value of resistance and and then which the color code. So basically for the resistance one is orange black, and resistance 2 brown black red, and resistance 3 is blue gray brown, and resistance 4 is yellow violet and brown, and resistance 5 is orange white and brown. So as the value is 330 ohm, 1680 ohm, and 417 ohm and 390 ohm. So next slide please. So this is the actually value and the measure that I get after I calculate all the value that given, and so that the major value that I get after calculate all. Next slide please. So that's all for me. I will pass to
Me.
I will pass to Zamzam.
Alright, I will continue from here for the lab 3 presentation of the superposition theorem. Alright, the objective of this lab 3, which is the first one is to measure and calculate the current in the each branch of a series of parallel circuit. And next objective is to verify the superposition theorem. Is it valid or not to be used in the series parallel circuit? Alright, the key law that I use in this lab to make this lab work is the superposition principle, KCL method, and Ohm's law. The circuit that was you can see as on the right slide, there is a circuit that the task asked me to recreate in the simulation, which is have two power source. The first one is a 10-volt power source, and the next is a 12-volt power source with 3 resistors. All right, next slide. All right, this is a procedure for to complete this task. Yes, like 9 procedure. The first one is to construct the circuit as shown in the question. And then the second one is to measure the value of IA, IB, and IC. The 3 is to remove the 12-volt source and use only 10-volt source. So what I need to do is actually I need to remove the 12-volt source, which is or it's like just remove it and replace it with a link or a wire connect. So there is only one power source, which is 10-volt. And the number 4 procedure is to measure the value of I1, I2, and I3 by using only the single power source, which is 10-volt. No, number 5, to calculate the I1, I2, and I3 to see if my calculation similar or almost exactly as a measured value. And number 6 procedure is to remove the 10-volt power source and use only a 12-volt power source. This is almost same like the previous one, which is I need to measure the value of I4, I5, and I6 with only a single power source. And then I also need to calculate to see how the value is, like, is it almost mesh or not? If it's mesh, then it's accept the superposition theorem lah. Okay, and number 9 is to superimposing the letter of the two diagrams, which is I need to using the value that I get from the single power source of 12V and 10V. I need to add both of them, so to see if it's really same as like when we use the two power source. All right, next slide. Okay, this is simulation I make to do this lab, which is I do the simulation in I create the simulation in every circuit application, and then on the right we can see that I have removed the 12-volt power source and used only a single power source, which is a 10-volt, and you can see the reading there. All right, next. All right, I will explain about this slide. From the right, you can see I use only 12-volt power source. This is where I mentioned previous that I need to remove the 10-volt power source and use only a 12-volt power source, a singular power source I mean. So when we remove that, I get the readings of each of the current, like 12-volt, 3.97 volt, and the current is 9.8 mA, 5.83 mA, and 3.97 mA. Okay, this is where I use only a single power source of 12-volt. On the right, explain about how I use the superposition principle to calculate the current in circuit. This procedure is used to measure the value, which is like, should I get same value like how it is on full circuit when I'm using only a single power source. So the superposition principle is about I total equal to V1 only, single power source of 10-volt only, plus V2 only, single power source of 12-volt only. So for the IA, I get for using this superposition principle, I get the value of IA as 3.01 mA, and IB, I get the value of 4.94 mA milliampere, and IC, I get the value of 7.95 milliampere. Okay, next. Okay, in the table we can see there is a value I get in the lab, which is an on full circuit, which is with 10-volt and 12-volt both simultaneously on. I get the IA reading of 3.01, and using superposition principle, I also get the 3.01 mA. There is no difference, which is no discrepancy. And IB, I also get 4.94 mA for the full circuit, and using superposition principle, I get the same amount, same value. And IC, I also get same value for both, which is on full circuit and using superposition principle. There is no noticeable difference on the value I get. For the observation, it is proof that the superposition theorems works even with multiple voltage sources. We can see our calculated measure result for IA, IB, and IC matches exactly, perfectly. There was zero discrepancy between theory and the practice. This confirms that superposition theorem is an accurate and effective tool for analyzing linear circuit with multiple sources. So for the conclusion of the lab 3, I will say that superposition is a reliable method for analyzing a multi-source linear circuits. It is to simplify the analyzing while maintaining a full accuracy. I can see full accuracy because my reading, I get zero differences. Okay, next. All right, lab 4, I will pass to Zaim to continue presentation. Thank you.
Hello, madam. My name is Muhammad Zaiman, based in UK. Now I'm going to present my lab, that is lab 4, determinant theorem. The objective of this lab is to simplify a complex circuit into a single voltage source and resistor using Thevenin theorem. The key law and formula used in this lab is Ohm's law, and the key formula is V equals to E minus I times R. Okay. And at the right hand side, that's the circuit that we're gonna use for this lab. Okay. The procedure of this lab I summarize into four procedures. That is, to measure IA, IB, IC in flow circuit. Second one is to find open circuit voltage VOC and Thevenin resistance ROC. And number 3 is calculated equivalent circuit. And lastly is to reconnect load and compare IC again. Okay. As you can see here, this is the simulation picture. The picture taken during my attempt to do the simulation. All the simulation was done using every circuit, a software name of every circuit. As you can see here at the at the left hand side, the value of IA is 3.01 milliampere. The value of IB is 4.94 milliampere, and the measured value of IC is 7.95 milliampere. Okay. Then the procedure requested me to remove the 1K ohm resistor. As you can see at the right hand side, I replace it into VOC and into voltmeter as requested in the procedure to measure the VOC value. Okay. Then the textbook requested me to remove the voltage source. As you can see here, the voltage source of 10V and 12V. They request me to remove it. It is to measure the value of ROC. That is the total resistor in the circuit minus the 1K resistor. Okay. Then the procedure requested me to put a voltage source, the value of VOC measured, and the a resistor, the equivalent of the value of ROC, that is as you can see that 372. The actual value is, when calculated, is supposed to be 371.7, but due to this every circuit won't allow me to put a resistor with a decimal, so I change it into 372. Okay, here at the right hand side is the calculation. The calculation part of this lab that requested by madam. All of this calculation was done by using the KCL method and the Ohm's law and basic resistor combination value. Here you can see the value. Madam can refer the very detailed calculation at the report. Okay, here observation. This is the value measured and calculated gain by using only simulation only. This just to avoid any misunderstanding. Okay, for observation, the value of VOC and ROC is 10.9 and 372 ohm. And the value calculated IC is almost the same with the measure. IB same like IC, IA and IB also closely match. This verified data we use. In conclusion, Thevenin theorem greatly simplifies circuit analysis. It is especially useful in troubleshooting and designing real-world systems. It is applicable to circuit with multiple sources when combined with superposition. So in summary of finding, lab 1, that is the Ohm's law, confirm linear V minus I behavior across the different resistor. Lab 2, serial parallel, accurate match between calculated and measured values. Lab 3, superposition, validated theorem with 100% match between measured and theoretical current. And Lab 4, Thevenin reduced complex circuit accurately confirm simplified model are effective. Thank you very much, madam.